I'm coming with question number 13 of Pathfinder Newton laws of motion. My dear friend, before starting to reading of this question, I want to tell you this you can learn from this question what is the extension is in massful spring, means because of the weight of the spring how much extension will happen and how to derive. So I will discuss the derivation of extension in a spring because of its weight, and then I will proceed. So what is the wording of this question? The question is saying that length of a 1 meter long uniform spring of mass 50 gram increases by 2 centimeter due to its own weight. If it is suspended from fixed support, how much load should be suspended from the lower end of this spring so that the total extension becomes 10 centimeter? Okay, so what is the question is saying that I want to explain. First of all, you can say that, sir, here one spring is attached. This spring is the massful spring. It has a mass. Let's say mass is a small m, and some natural length is L. But because of its own weight, some extension will happen. And we connect one block of some mass capital M. Sorry. Because of this block, some more extension will happen. This is 10 centimeter. So means if the block is not connected, then because of its weight, it has extent is 2 centimeter. So let's say I want to draw the extension in a spring due to its weight. My dear friend, so this is your spring. Okay, and this spring length is L. So I am considering a x distance from bottom at a distance x, the dx elementary part of this spring. Okay, this dx length. Okay, so let us assume the extension in spring, in elementary part of the spring is let's assume it is delta x. Okay, so dx is the length of the spring, and in this dx, the delta x extension will happen. So I want to draw this dx line separately, then you will understand. So this is the dx length for magnified view, and this dx length some extension will happen. So if you talk about this point, then here tension T is developed, and here it is tension increases. So here the tension is T plus dt is increases. Okay, and my dear friends, I tell you one thing. At this point, because of its own extension, here one force is acting dk into delta x. So in case of equilibrium, we can write T is nothing but it is dk into delta x. My dear friend, let's assume I tell you one thing. The most important property of the spring is the spring constant is equal to the Young's modulus area of cross section over length. We remember this, and in separate video I will discuss the derivation of this spring force constant. So here you can see the K is directly proportional to the natural length. So if I am talking about the dk, then dk is also directly proportional to 1 upon dx. So my dear friend, I can write the value of dk in terms of k. So here I want to write, so dk by k is equal to L by dx. So be remember, Now, here I am writing the value of dk is k L over dx into delta x. And be remember, please don't be confused, delta x is the extension in spring and dx is the length of the elementary length of the spring. Now my dear friend, what is the tension? So look at this part. Look at this extension remaining part. So mass of this part is hanging and the total mass of this part is m by L into x. Okay, so we can say that this mass into g, this is equal to the tension. So tension is T is equal to m by L x g. Finally, we can equate these both equations and after equating, you will get the result. So m by L, okay, I'm extremely sorry because I mentioned the small m is the mass of spring. So here I want to write small m. So this is the small m. This is also small m. So here you can say that, sir, m by L xg is equal to kl by dx into delta x. Okay, now I want to go with the simple derivation. So you can say that the delta x is equal to, it is m g by L into L. This is also small, so KL square x dx. Now integration on both sides. So total length is from 0 to small l, then 0 to small l, and extension will happen 0 to delta x. So we can write the extension in spring is, the extension in spring is the delta x is equal to mg by kl square into L square by 2. L square cancel. The delta x is equal to mg by 2k. So next time be remember, because of its own weight, the spring has an extension which is equal to mg by 2k. This is a very important concept, be remember. Understood my point? Now remaining questions I will discuss. So finally calculate the elongation or extension in a spring. You can say that let capital M mass is required to what, how much amount? Total extension, to increase the extension in spring. So finally, you can say that total extension is becomes, we can say that total extension is 10 centimeter. So total extension is 10 centimeter. So 10 centimeter extension, first of all, because of its own weight, mg by 2k, and plus capital mg by k also. So generally in this question, mg by 2k is given 2 centimeter simply. So here I can write 10 is equal to 2 plus mg by k. Finally, mg by k is equal to 8 centimeter. So now the mass m is equal to, it is 8k by g. Now I want to put the value of k here. So I want to calculate the k from this equation. The k is equal to g by k or k by g. You can say that the k by g is equal to, it is m by 2 delta x. So m is given in this question. M is what? It is 50 grams. So I want to write 50 gram divided by 2 into delta x is 2 centimeters. So here it is also 2 centimeters. So that is called 25. So here I want to put the value of 8 into 25 fine by 2. So you can say that it is nothing but the mass is 100 gram. So you can learn the some most important concept from this question. So thank you so much for watching this video. If you have any comments, any doubts, so you can write in my comment box. Thank you.